Hello everyone, this is Ali Reza. In this episode, you may notice that I moved until failure and until success above interrupt. And that is because these nodes are not that hard. We will implement them, and until failure and until success, my original thought was that they would have two outputs. But then I referred to one of the documentations available, and that was from this guy, behavior designer, because this was the first place that I see these two nodes, and I read the documentation. It says it will run the child task, so it will have only one child until the child task returns failure. If it returns failure, then it will return success and goes up. And if the child task returns success, it will returns and goes up. So those looks like easy nodes to implement. So let's see, where did he categorize them? Under decorators. Well, we have just failure and success. Let's add them here, okay? So class BT until failure node and BT until success node. Under decorators, we have BT, oh come on, phew, look at me. BT, cool, wow. BT until success node schema. And BT until failure node schema. So the easiest part, BT base node schema and node. BT base node schema node. BT base node and BT base node. Okay, so if you think about it, we will need our initialize and tick. In initialize, in here we have nothing to do. Maybe not, I'm not sure, we will see. So initialize tick and just the initialize. This is one of the nodes that has no params actually. So initialize, come on. Okay, so we have one output, so we say outputs at 0 dot multi-connect equals to false. So it won't do the multi-connection, okay? It will have only one child. Now, in the tick method, we will say that this is until failure, okay? So we say var child equals to outputs 0 dot connection node 0. But before that we say if outputs dot is null or empty, or outputs 0 dot connection node that is null or empty. We set our state to be errored and we return base.tick. Then here we say we have the child. We say var child state equals to child.tick. So if the child state equals to failure, that is when we set our state to be equals to success, because this is until failure, okay? And now we say parent graph that active node equals to our inputs at 0 dot connection node at 0, and we return base dot tick. Otherwise, we do our state to be our running state. So we are running, okay? And we need to handle something else. If child state equals to running, we say parent graph dot active node equals to the child, and we return base dot tick. Otherwise, we set ourselves to running, because if it's not failed, if it's not running, then, well, obviously it either succeeded or failed or errored. So we say if child state equals to errored, we do two things. We set our state equals to the child state, so we errored out, and we return base.tick. So at this point, we know that the child was success, so we keep running and we say parent graph active node equals to this. So we are the active node for the next tick. I think that's it, you know. So for this guy, we need one of those schemas for this. And we say until failure node will tick its child as long as the child result is not failure. The moment the child returns failure, this node will end its job and return success. In case the child node gets the error state, this node will get error state. So, and that is until failure. So until failure, create that. Read only and equals to dot load not texture, no, color with manifest, and the resource is until failure. Build. Go back to Unity. Come on. Okay. Delete this guy and add oh, I forgot the, okay. So inside here under decorators, we will have BT until failure and until failure. Build. So now I will add a success node here. So as long as this node is returning success, this guy will return running, and no matter how much I tick, it will return running. The moment this guy returns failure, this will return success and goes up. As simple as that. Okay? So that's our until failure. And the same concept is until success. So I will get this guy's tick, and yeah, I was right, you don't need initialize here, into until success. And we just flip stuff around. So we say if the child state equals success, that is when we succeed. If it's running, that's running. If it's error, that's error. Otherwise, we are running. That's it. So the schema. Until success node will take its child as long as the child return result is not success. The moment child returns success, this node will end its job and return success in case the child node that's it. Okay, so until success and until success. Let's create this guy. Read only equals to something dot color from the manifest, and it's until success. So let's build, and let's go back. So now I will add another one until success this time. And if you want to compare that, this was until failure, okay? It's just success or failure. Connect. So I will add a failure. Now this guy should keep busy, no matter how much I tick it, okay? So no matter how much I tick it, it will keep running and it will tick its child unless it returns success and it goes up. There we go. So that's our two more nodes. Wasn't that hard, was it? Now interrupt. Let me see how much time I have. Oh, a lot. Okay. Here's the help that the guy has on interrupt. He says that interrupt will run a task, a child task. And when the child task meets a condition and he doesn't know, and it doesn't, well, he is implementing his totally different than mine. He has a node that calls interruption. Okay, I don't have any node like that. So in our case, if the child node returns success, that is when this node will go to the second child and says, hey, that child, and not only that child, all his branches, if anything is running, interrupt, become inactive, basically. And then it returns success. That is my understanding of this documentation. I hope I'm right. But before that, let's create the repeat node, because repeat node is fairly simple. If you look at, again, another available documentation, it will return, it will run its child task. So the child task is, again, this is one of those nodes that the output is not multi-connection until the specific number of times. After that, it will go up. Now, there is this field that you can set that basically tells if the child is failed, go and say failed and go up, or say success. I don't know. Okay? So you can have repeat for count number of times, repeat forever, or basically one of these two. And then this flag tells you to ignore the failure of child or not. Okay? So I wonder, it has the option to continue the execution even if the child task returns a failure. So this is one of the problems. It doesn't say that if the child is failed, should I return failed or should I return success? Well, I think this is one of the things that is well, personal decision making. Because trust me, in behavior trees, we have some of these nodes that we need to sit back and think and say, okay, I want this node to behave like this. So let's create that, and we have that repeat. Okay, so let's close these guys. And repeat is under, again, decorators. Good, we have more decorators now. So bt repeat node. This is a base node and node. Under here for decorators, we have bt repeat node schema, and it is bt base node schema and node. So let's override our initialize, and as we said, outputs of 0 dot multi-connect equals to false. Now we need an enum. So under enums, I will add an enum and I will say repeat condition, repeat node condition, or I think I called that one parallel conditions or something like that. Yeah, repeat condition. So repeat condition is count or forever. So it's one of them, and forever is one word. So it's one of those two. And of course, we will have a serialized field of public repeat condition. Then we will have a serialized field public int count, and a serialized field of public bool ignore child failure. Okay. By the way, I just remembered something. In can here node, if you recall, sorry guys, I just remembered this now. We had this hard-coded curve. Well, that would work if my curve was up to, I don't know, 200 meters to 50 meters. But as soon as I would pass 256, I would have to add one of these guys again. So I ended up with a very simple while loop. I have an int, a float, I add one key with them, so 1, 1. Then while the n multiplied to is less than source.max distance, I multiply it by 2, I divide k by 2, I add the curve. At the end, I will add the source max distance with the value of 0. Now I know that in each tick, I'm generating this curve now, okay? And it's not optimized at all, so I need to put a to-do, and I will say critical optimization needed. We don't want to generate this curve at each tick. I will come to that later. I couldn't make my mind to have this curve always sit on the node, or just, you know, take a look at the first tick and see if it's null or it doesn't have any curve, generate the curve, and then get done with it. And well, that would be a serialized field again. I didn't make my mind yet, so that's a to-do for later. And sorry, I forgot to mention that. Now come back to the repeat. We will have our overrides for initialized tick, and we need the reset. Now that I think about it, we need a serialized field of private int count. Okay. So at the start, again, we say count equals to count plus 1. Same reason we had for the counter. Okay. So here we say count equals to the capital count plus 1. Now, in here, you say count minus minus. If count is less than or equal to 0, and the condition equals to count, then of course before anything else we say if the outputs dot is null or empty, or outputs dot connection, no, not that, connection outputs 0 dot connection node dot is null or empty. Of course this is our error state, so we say state equals to error and return base.tick. Okay. Now if we are in count mode and we already counted all the way, so we say our state equals to success parent graph active node equals to our inputs 0 dot connection node 0 and return base.tick. Okay. Other than that, well, let's think about this. Let's say we want to tick 2 times, so we have 3. The first one will become 2. The second one will become 1. The third time, yeah, that should be equal to 0. Okay. Other than that, if that's not the case, so we still have to tick our child. So we say var child equals to our outputs of 0 dot connection node of 0. Then we say var child state equals to child dot tick. Now here is the conditions. If child state, come on, child state equals to error, that's the easiest one. We say our state equals to child state return base dot tick. Okay. Other than that, now child can be running, child can be success, child can be failed. So if child state equals to running, then we say parent graph.active node equals to the child. Before that we say state equals to running, and we return base.tick. Now if we succeeded, we return. That's the base of it. Okay. If we failed, we need a new condition. So if child state equals to failure and not ignore child failure, then we say, and what's your running? Oh, okay, one extra. There we go. So if not ignore and we failed, then here is the decision to make. Should we fail or should we succeed? Let's do it this way. Let's give the flexibility. Serialized field public bool should fail on child failure. Then we say state equals to should fail on child failure. If that's the case, evaluation failure. Otherwise, evaluation success. Boom. So that's that. Now, and of course, return base.tick. Now here's one more thing. We should count if only we are in counter mode. So if condition equals to count, then do this stuff. Okay, and of course that is redundant now. There we go. If we are not counting, then we are ignoring the count. Now if child returns success, we just, so we say state equals to running and return base. Let's see if this works. And I totally forgot that I need to add it in here. So on under here, we'll say repeat repeat. Okay, now build. So I will go with a success node because I don't want to deal with my properties yet. I have to deal with my properties now. So what did I have that had integers? Counter. So that action counter. Okay, let's get this guy. Go back to our schema, and now we need to alt insert override our draw properties. So that and one of these end regions need to go up. I ported the region inside region. Okay, so this is count and BT repeat node. Count BT repeat node count. But before this, we will have more horizontals. So the one is condition. So we have our condition equals to enum pop-up of the condition, and we need to typecast it to repeat condition. Then we say if this guy equals to count, then do the GUI layout here. Then we have another horizontal. Well, one of the nodes had a Boolean. Which one was that? I don't remember. Okay, so this is ignore failure equals to ignore child failure equals to toggle ignore child failure, comma GUI layout dot width. I think it was 15. So then we say if not ignore child blah, we want another one of these, so and we say return failure with child, and it would be, well, actually now I remember these guys need to be one down. There we go. And this would be should fail. Should fail. Build. So we are on count. Let's make 3 times. So yeah, that's okay. So if, sorry. Well, that's correct. Oh, sorry. If I checkmark this guy, that was up here. Okay. So let's see. This guy should tick this guy for 3 times, then it will go up. 1, 2, 3, success. Okay. Now, ignore failure. And we are ignoring the failure, okay? 1, 2, 3, goes up. Good. If we shouldn't ignore the failure, on the very first try, we say success. Because I didn't say return failure with child, okay? So if I say return failure with child, now we fail. That's exactly what I wanted to see. So we have our repeat. Now, if I say ignore, and by the way, if it's checked, then we need to do something. Well, let's see. I will check mark this, then check mark this, okay? And I will go forever. So I will tick this guy forever, ever, regardless of its state. So basically that's, if you set this node to be forever, this will lock your node for the behavior tree forever, unless you change it somehow, and I don't know how. Actually, I know how. So we say public void set condition with a repeat condition, and we say our condition equals to condition. Although you don't need this because, you know, these are public variables. These are public fields. So yeah, you can pull the node out and do whatever you want with it before the next tick. So that's it, you know. And that's our repeat. The only thing remaining is to set our help and the easy stuff, basically. So it's repeat and be careful we don't do that. Number of ticks that node will tick the child. And I didn't add these parameters for few of the nodes. We will add it at the end of the chapter when everything is working. So repeat node will tick its child in different ways. If set to forever, it will tick the child forever and keep itself as running. This will lock your tree. If set to count, it will tick the child the number of times that was set in the parameters. If set to ignore child failure, it will totally ignore the child's failure state. Otherwise, if it was set to false, the moment the child returns failure, it will decide to fail or succeed based on the last setting on the node. That's it. And again, I'm not adding parameters description for time being. So do this, read only, repeat.color, manifest, build, and now If I delete the node, if I add the repeat, I have my graphics and my help. Okay, and that's it. So the count, I would initialize the count to be at least 1. Build. And that's our repeat node. So we had until success, until failure, and repeat. Now comes the interesting ones. Well, reflection is basically just reflection stuff. Compare value is again interesting but easy. Interrupt, however, I wonder how to handle it. I really wonder how to handle it. Yeah, I think interrupt will be one of those nodes that will have 2 outputs. But then how to tell you which output is which? Well, interrupt can wait for the next video. Until then, have fun everyone. Bye bye.